Hi everyone, I'm Mike Foster. Thanks to our friends over at Zeiss and at Red, we are doing a technical deep dive on the Zeiss CinCraft inside-out camera tracking solution. So let's get started. So the first item that I would like to talk about is the cam bar. Think of this as the eyes of the system. This cam bar is going to be mounted on your production camera. Now there are different mounting points. There's your standard 1/4-20 as well as your 3/8/16, and there are RE anti-twist pins, which I really appreciate. So there's multiple lenses on the bar, but currently Zeiss is only utilizing 2 of the lenses. It's the left and the right. The 2 center ones they're currently not using, but I'm sure they're cooking up something for the future. Now to connect this cam bar to the system, it has a fixed cable coming out of it, and this snake has 3 cables. It has a USB-C, a LEMO, as well as a BNC. I would say this cable is about, say 1/2 meter. This cam bar connects either into the link or directly into the origin, which is the server of your system. Now let's talk about the link. The link is an optional device that you can have within your workflow. The reason why you would go with this link instead of the origin is because you would want to have a smaller footprint on your camera. Because the cam bar has this fixed cable, it has to be about 1/2 meter away from either the link or the origin. And this will be adjusting all of your data from the cam bar, as well as the encoder data and Genlock if you are utilizing Genlock. Now, if you decide to go with the link, it's still not completely wireless because you will need to hardline the link directly into your network or directly into the origin. Let's talk about the origin. The origin is the server. It is the brains of this entire workflow. You'll be running your CinCraft Scenario software directly from this unit. Now, you can either control this wirelessly, or you can control it directly by patching directly into it or on your network. I recommend that workflow. In addition to this hardware, Zeiss provides you with all the cabling that you'll need, and I highly recommend using their cabling and not a third party. Additionally, for encoder data, Zeiss pretty much has you covered in terms of everything that's on the market. Of course, you'll get all your power adapters, your 2-pin LEMO power or your DTAP for the link unit, as well as all of the cables for the encoders. So if you want to get lens data, Zeiss has provided you with every solution out there. Whether you're going directly from a smart lens or you're coming from an ARRI camera or a manual encoder as well. To get power to this, you can go off the camera's battery, which then will send power to your cam bar. If you use the origin, you cannot take power from the camera and would have to use the power adapter that's provided within the kit. Now let's build it. So let's get started with how to mount your cam bar, and for this example, we're going to be mounting the link unit onto our production camera. What we have here is we have a Komodo X Red. Thank you, Red. And with it, we have the Tilta Advanced Kit. So this includes the top handle, a cage, as well as a V-mount battery plate. What's great is that this gives us lots of different mounting options. Every build is going to be different, every camera is going to be different, and every camera department is going to be different. So you want to be as accommodating as possible while still being able to do your job. For this example, I'm going to be going off the top handle. For me, I'm using a bright tangerine handle extension. What I love about them, 1, they're really solidly made, and 2, they have anti-twist pins. You're always going into the exact same spot every single time. How I'm going to attach the cam bar to this handle extension is I'm actually going to use the Condor Blue mini plate. The foot and the shoe have anti-twist pins. So if I take this off and put it back on, it's going to be in the exact same spot again. If I take this off and put it back on, it's going to be the exact same spot again. And when I put it on here, it's going to be in the exact same spot again. And what's nice is that if I need to take it off really quickly for whatever reason, all I have to do is this. I don't need to unscrew anything or anything like that. I just slip it right out of the shoe and we are good to go. What I have found is that the parts for the anti-twist pin, I'm not going to be able to put it straight forward, which actually kind of works to my advantage. So instead of doing the cam bar here, it's actually going to be about a 45-degree angle panned to the right. And just like that, we're mounted. This is nice and secure. It's not gonna shake around. It's gonna be out of the way of the camera operator because it's gonna be on the assistant side. I can use more of these handle extension bars, the HEBs, to build out different positions, and using these Cinelocks, I can find different orientations. Maybe it's going backwards, or maybe just all the way like that. Or if I wanna go up, whichever way I wanna go. Great, so this is all set up. Now I'm going to attach our link. I'm gonna use one of these magic arms. This is from Aperture. So I'm gonna go off the side of the cage, and I'm gonna have my ports going to the cam bar on the top side. So I'm gonna twist it like this, So it's off the camera just enough so that I can still access all of these buttons, but it's still close enough where I can get my fixed cable to this unit. So just gonna patch it in. Great, now I need to run power to the link. I'm going to use the power cable that is provided by Zeiss. Now for the cam bar, because I haven't calibrated this cam bar yet, I'm actually not going to clean up this cable because during the calibration, I am actually going to take this off of its bracket and I'm gonna move it around. So I'm gonna leave this cable free for right now, and then I'll clean it up after the calibration. Let's move forward with calibration. I've set up our server at our station, and I've been running our clean feed from our camera as well as our Ethernet from our link. There are three things that we need to calibrate. First, it's gonna be our environment. Then it's gonna be the cam bar to the sensor of our camera. And then it's gonna be the orientation of our world space. Let's get started. So the first thing we're going to do in our software is start a project. I've already started a project, so I won't go too much into this. In the first tab of our equipment list, we're gonna list our camera, sensor, as well as the crop we are using. For this scenario, we are using our Komodo X from Red, 6K Super 35, and we'll be doing 6K at 16:9. Once I add my camera, I'm gonna add the lens that we're using. Again, Zeiss was very nice to let us use the Supreme Prime 35. I love that there are virtual lens packages that you can upload right into the system, patch that lens in or patch that profile, do a little bit of tweaking, and you're off to the races. Excellent. Now we're gonna move over to our tracking page. We're just gonna let the system use natural markers and learn our environment. The first thing that we wanna do is we wanna set the cam bar. We're gonna go into the cam bar offset assistant, and it's gonna guide us through the process. You don't need the assistant to help you out, but it does help. I'm gonna click Start Cam Bar Offset. Now that we're going to calibrate the cam bar, we're gonna make sure that we're using the correct equipment list. This list is being pulled from that first tab that I showed you earlier. Now that we've selected the right camera and lens, we can click on Next. And we wanna confirm that our encoders are working. For this example, thankfully, we are using a smart lens, which is the Supreme Prime. So we're able to patch directly into the lens and get encoder data. We could also use manual encoders or pull this data directly from the remote follow focus if we're using those systems. We are getting a warning that says the current field of view is quite narrow. Now we are using a prime lens, so our lens is as wide as it possibly can be. If you are using a zoom lens, be sure to do this process on its widest focal length. Excellent. The first step of the cam bar offset is getting our calibration board in frame. So as you can see, we have our instant recovery board set up on a C-stand. And what I'm gonna do is I'm gonna get it in view of my camera. I'm gonna put it in focus. And what's gonna happen is that the system is going to recognize this known object, this calibration board, and it's gonna put 5 red dots on it. Then what we wanna do is we wanna get the cam bar seeing the exact same board. A little misconception is that you don't need to have the board in the view of both the production camera and the cam bar at the same time. You just need to have the system recognize them both at any point. The goal of this is to get this board in 3D space. So now that I've seen it in the production camera view, as well as the cam bar, it is now populated in our 3D view. Once that is done, we can hit Next. Now that we have that calibration board in 3D space, the system is going to recognize this known object and calculating where the cam bar is relative to the camera sensor. Sometimes through this process, you want to slowly pan the camera and the system is going to make some very slight adjustments. You don't want to go too fast or too crazy, and if the 3D model of the cam bar zooms out into space, that means you don't have enough feature points and you're gonna wanna start over. I would recommend keeping the calibration board in view of the production camera. The calibration is a known object, and what it's doing is it's using the calibration board as an anchor point for the 3D space to help it understand the relationship between the cam bar and the production camera. Once you've confirmed the offset within the system, finish offset estimation. The green markers within the 3D space, you can compare those markers from the cam bar view with the production view. So for example, this mark, or right there on the wheel of our cabinet. That's also pretty close. Now that we've set up the relationship between the cam bar and the production camera, now we need to calibrate and understand the orientation of our world space. What's the XYZ of our 3D space? For this example, we're gonna have our Y-axis up and our X looking forward towards our LED wall. We're gonna click on Alignment, Edit World Alignment. Now there's two ways that you can go about setting your origin, which is your 0, 0, 0. You can either go into the software and click on a point, or you can use the calibration board. For this example, we're going to use the calibration board. On the other side of the calibration board, the registration object, there is an X and a Z, which helps you understand which way you're setting your axis. Now the 0, 0, 0 point, the origin, is actually around the corner of this fiducial. I'm gonna set this on the ground, and then we're gonna get in view of the camera, and then the system will recognize it, and that's how we're gonna set our origin. Once I have the board in view, the system's gonna recognize the board automatically and set our 0 point on the registered object. Now that we've set our origin, there's still a few more tweaks that we wanna do. One, we wanna make sure that our floor plane is nice and level, as well as the height to the floor is set. There are a few ways that you can do this. You can either use the gyroscope that's in the system to help orientate it, or you can grab 3 sample points. Essentially, the sample points is I'm gonna take my camera, lock off the fluid head, and get 3 different points with the registration object in view of the camera. For this purpose, I'm just gonna use the gyroscope as it's pretty simple and pretty easy to use. I'm gonna check my floor height, and what I'm gonna do is I'm going to measure from the ground to the sensor of my camera. So we're about 135. So our height is a little off, so we're gonna add. Now as we move through this, we can adjust the position of our 0 point, we can fully move it around, we can adjust the floor height, adjust the orientation, and fine-tune the up axis as well. Gonna click save, and there you have it. We're all set. Overall, the calibration process is pretty straightforward, and the software is very intuitive and walks you through each and every step. So I recommend the first time you're doing this, take your time, read everything in the assistant, and after a few times, you're gonna have this process memorized and you'll be able to do it blindfolded. What I really like about this system is that it's very easy to learn how to use it and to understand how it's using it. This video, we've only gone through the very basics of how the system works. There are additional advanced settings within the software, although going through it personally, I hope there's gonna be more settings that we can tweak to help refine and stabilize our camera tracking. Another challenge, and maybe this comes down to my understanding of the system, the world orientation. You can set your 3D world space within that system, and the camera tracking unit can understand where it is in that 3D world space. But what I've been finding with almost all inside-out solutions is that the calibration, the tweaking, and the quality check of your 3D world space is lacking in most inside-out solutions. Yes, the system understands where the cam bar is in 3D world space, but does the 3D world space match our world space? It's hard to fully confirm that, and what I found is that every time I do something, it's always just a little bit off. I would like to see more tools when calibrating the 3D world space, maybe a little bit more reprojection error or more feedback in the software that lets you know what the system's actually doing under the hood. You know, it's really intuitive and it's always learning, which I really appreciate, but it's hard to understand what exactly it's doing, and when the system goes bad, as an operator, how do you know it gets bad, and what are the next steps in the troubleshooting process to help you get camera tracking up and running again? So for stuff that I would like to see in the future, one, I would like to see smaller hardware. Of course, that's a long process, and now that the software has been really upgraded since the previous version, I'm hoping that the next iteration of the Zeiss CinCraft Scenario comes with a smaller footprint that will be going on to the production camera. Additionally, I would love to see a system wireless, but also when you're working in virtual production, especially when you're in a large virtual production volume, wireless is not reliable. So having a fixed cable coming off the production camera, SDI feed, and a Cat6 might be a necessity. So keep in mind when you're doing that on projects. Overall, I think the Zeiss CinCraft Scenario system is a very good, quick, intuitive, and low-profile solution compared to everything else on the market. I love the fast setup, I love the software and how intuitive it is and how it walks you through everything. And since Zeiss is a lens company, they're really ahead of the curve when it comes to integrating lens calibrations within a tracking solution. Thank you again for watching. We really appreciate it. And I want to thank our friends over at Zeiss and at Red who made this video possible. If you want to check out more technical deep dives, please like and subscribe to our channel, and thanks for watching.